In the last video, we have discussed dimensions of physical quantities and dimensional analysis we have done, and we have seen applications. Now we are going to take some questions from previous year question papers of NEET exam. Here we have one question from 2019, and the question is, in an experiment, the percentage of error occurred in the measurement of physical quantities A, B, C, and D are 1%, 2%, 3%, and 4% respectively. Then we have to obtain maximum percentage of error in a measurement X, where X is expressed as this way. Okay, so this is basically easy one. What we need to do, we have to take into consideration each and every uh, errors, you can say here, and we have to be careful about power associated with those physical quantities in the expression. So how can we continue? To get maximum percentage of error in measurement X, we have to take the error coming from A, which is 1% along with power. Here we have multiplied this. This is the way to check how the error will be propagated. And here we have 1 by 2 into 2% plus 1 by 3 into 3% and plus 3 into 4%. Actually, I have made a detailed discussion video on this topic. Actually, not only in this topic, but all the topics which are there for units and measurements, theoretical part on. So you can go through the videos if you want to get better conception about this thing, and you can find that video in the same playlist here. So you can calculate this, and I hope this will be 16%. 2, 1, 1, and then 12. Okay, 16%. Now moving to the next question. Next question we have taken from the 2020 paper. Screw gauge has least count of 0.11 millimeter, and then we have 50 divisions on the circular scale of that screw gauge. We have to find out each. Actually, we have one formula here. Okay, soon we are going to discuss how it comes. Least count is each divided by number of divisions. Okay, on the circular scale. So least count is 0.01 millimeter, and then pitch will be, we can get from here, pitch will be 50 times of this 0.01 mm. And if you can calculate it, I hope you are going to get this is 50. We can multiply uh, with this thing 50. This will be 5 into 0.1 millimeter, and then ultimately it will be 0.5 millimeter. You can do in your own way, whatever you feel comfortable. So this is the list count. Sorry, this is list count, and this is pitch length. Okay, so how it comes? Let me introduce screw gauge and discuss a little about that, so that if we have some more questions about that, we can solve. So this is experimental part, actually, laboratory part. Here we have a diagram of screw gauge, and this diagram has been taken from mm, NCRT lab manual. Look, this is a U-frame, and you can call limbs here. This is a stud. There is a projection of a circular rod-like structure coming out from this limb, and it has a circular face here. And this part is a screw. This part screw. So let me clear it. Then yeah, here also you will get a circular face on the screw side. And now you can see here on this screw there are threads. You have seen screw in real life. They have threads, because this diagram may not be very obvious, but yeah, you have seen the screw. So this is a screw part. Now coming to this side, starting from far right. Here, this is ratchet which you can rotate, and when you rotate this ratchet, this head will move. Whether it can move this way, and if you rotate in the opposite way, it will move in the opposite way. Okay. So actually it slides on this cylindrical part which we call sleeve, and then when this head slides on this cylindrical part, corresponding to that, here this screw moves forward or backward, and then you can place a wire here and you can take readings from here and you can say what is the diameter of the wire. So how can you take reading, and how can you say that diameter of wire is this much? So for that you have to know these scales, and you have to know how can we measure that. So this is linear scale on the sleeve, and this is circular scale on the head. So look, if you rotate, now you have to be a little bit careful about these things. If you rotate this right side, and this circular scale goes once complete. So in this particular diagram, it has 100 divisions. That means this circular scale has 100 divisions, and if it rotates completely once, so in one complete rotation, it will move some distance, maybe forward or maybe backward. Let's say forward direction. So it is moving forward direction, some distance. So in one complete rotation means in 100 divisions, it moves forward some distance, and that distance will be equal to the length, or you can say distance between two consecutive threads here. Why I am saying that? Because when you rotate it once, I mean a complete rotation, you will go one pitch ahead, sorry, one thread ahead, and you have moved some distance. This is very minute, but you have to understand that there is some distance between the two consecutive threads. Let's say that distance in this particular case is 1 millimeter. So in one complete revolution, this circular scale completes its 100 divisions, and this head moves 1 millimeter, the same length which is between the two consecutive threads. So this length we call each of this screw gauge. And then if you want to know what is the smallest measurement that this screw gauge can do, so you can find out easily from here, because in 100 divisions it can measure 1 millimeter. So in one division on circular scale, it can measure 1 millimeter divided by 100. So that will be the least count of this screw gauge. And I have already used this thing on here. Least count is each, that is the distance traveled by the head in one complete revolution, or you can say the uh, distance between two consecutive threads on the screw, and this is the number of divisions on the circular scale, which is marked here. Okay, so we have this formula and we have solved already this question. Let me introduce little more. So this is list count, which is nothing but each over number of divisions. Now suppose we want to measure diameter of a wire. Now we are putting a wire here, and let's say it, yeah, it is just touching both measuring faces, just touching this wire, and then we are getting exactly this scenario. So how can we get what is the diameter of the wire? For that, we have to check what is uh, the reading on linear scale. So linear scale reading, and plus I am measuring diameter of this wire. Okay, linear scale reading, and then we have to calculate further from this circular scale. So let me say that this is up to one only. Okay, one division. So circular scale reading, circular scale reading. Okay, and this is reading. This has no unit. This reading has no unit. These are only divisions. But Each circular scale division corresponds to least count. So we have to multiply with least count here. Finally, we have linear scale plus circular scale reading, and then this is reading also, and then into least count. If this circular scale is pointing 1, so circular scale reading is 1 and least count is 0.01 mm, and linear scale, look, I already told you that this is 1 millimeter division. So let's say it is just ahead of 7. So 7 millimeter and plus this is what it is ahead of 7, this much amount. So 7 meter plus sorry, 7 millimeter and then this much. So you can add this thing, it will be 7.01 millimeter. This is the diameter of this sample we have taken. I hope you have got the idea how we do measurement using screw gauge, and what is pitch, what is least count, and linear scale, circular scale, divisions. So these things are necessary to solve your questions. Okay, now moving to the next question. Taking into account of the significant figures, uh, we have to solve this thing. Okay, 9.99 meter, and we have to subtract 0.0099 meters. Okay, we can do one thing here. This will be 1, this will be 0, this will be 8, this will be 9, and this will be 9 meter. But look, here we have a number which has only 2 digits after decimal, and this has 4 digits. So while adding or subtracting, we should be careful about that. We have to keep as much as digits which are present in the lowest number in our question. That is, here we have 2 digits after decimal, so this is the lowest number after decimal. We have to keep the same thing in our final result. Then it will be in accordance with rules to determine significant figures. So we have to keep up to here. We have to drop this thing, and as this is less than 5, we can simply drop. So this will be 9.98 meters. Next question is, what is the dimensional formula of stress? So for stress, we can do one thing. We can take any formula which is simple. So we know about this. Stress is force perpendicular on a surface per unit area. So we can do, this is Newton and this is meter square. And now Newton, of course, we can do further simplification. Force, we can write mass into acceleration, and then we have mass, acceleration, and here area. Okay. So mass has dimension of uh, m, and acceleration has L t to the power minus 2, and area has L to the power 2. And then we can simplify further. Then we will get our final result, m L to the power minus 1 t to the power minus 2. This is a dimensional formula for stress. One more question we have from 2021 paper. Okay. If E and G respectively denote energy and gravitational constant, then E upon G has dimensions of. Okay, let us check what is the dimension of E first and then G, and then we can do that. So we have to find out any simple formula for energy. So energy is nothing but, uh, let's take 1 by 2 mv square. This is also form of energy, kinetic energy. So you can take here, this is dimensionless. This should have dimension of mass, that is m, and here we have L e to the power minus 1, and this is squared. Now we have to take dimension for G. Okay, so force equals to G, and then here we have some M, and M1, M2, you can write small m, capital M. There are two bodies always, at least two bodies for gravitational force, and then we have here R square. So this is force, and we have already uh, done this thing. For force we have obtained this relation, dimensional formula. M, this is mass and this is acceleration, if you can see properly. So this is acceleration. And then we have G, this is m square, and this is distance between the center of masses of these two bodies, so a kind of length, so it is L square. Then we have dimensional formula for this G will be, look, m square, and here one m is there, so it will be m to the power minus 1. We are transposing this thing this side, so m to the power minus 1, then it will be multiplied, so it will be L3, and then we have t to the power minus 2. So we have got this part also. What we need to do, we have to put it here. Okay, so L3 t to the power minus 2. Now let me make some space here so that we can continue. Okay, so m and this m inverse will be added up here. It will be m square. Now coming to this part, here we have L square. Look, here we have a square term L square, and this is 3, so it will be L to the power minus 1, and then we have t to the power minus 2 on numerator side and also on denominator side, so t will be 0. Here we have E by G. This is the dimensional formula for E by G, where E is energy and G is gravitational constant. Moving to the next question. What is the next? Yes, again from dimensional analysis. If force, acceleration, and time are chosen as fundamental physical quantities, then dimension of energy will be. Okay, so if we have chosen these physical quantities to be fundamental physical quantities, then we have to express energy in terms of these physical quantities. So energy, as you know, energy and work both has same dimension. So energy will be force time displacement, and displacement we can write in terms of acceleration and time. Look, S is ut plus half at square. We have discussed this thing already, so just focus on this part. Here we have acceleration and time as well. So if we want to write S in terms of acceleration and time, then dimensions will be A times T square. This is dimensional formula for uh, length if we are choosing acceleration and time to be fundamental physical quantities. So we can write here energy will be of dimension of force times A times T square. So this should be the dimensional formula for energy when we have chosen force, acceleration and time as fundamental physical quantities. Now moving to the next question. Is next. Yes, this is from 2021 paper. Okay. One more question from screw gauge. We can apply the concept we have just discussed. And here what is happening? Screw gauge has, screw gauge has how many divisions? 100 divisions on circular scale and 1 millimeter on main scale. That is, okay, we have discussed the same type of screw gauge already before. So now we have to check what is the diameter. So diameter will be, excuse my writing, but you should know this is diameter. Linear scale reading plus circular scale, but scale has divisions only, then we have to multiply with count. Okay, so Linear scale reading is 0. So we have 0 mm plus circular scale has 52 divisions coinciding with that. And then we have to find out least count. So here we have each given. Look, 1 millimeter completes in one complete rotation, 1 millimeter distance it completes, and then it has 100 divisions. So least count will be 1 by 100 millimeter. That is each by number of divisions. So it will be 0.01 and millimeter. You can write it 0 millimeter here, and here you will have 0. Sorry, plus here 0.52 millimeter. So ultimately you will get 0.52 millimeter. And yes, of course you can change it into centimeter also. So you will get 0.052 centimeter. No matter, you can change in other units also. Whatever be the matching in the your options given there, you can change accordingly to that unit here. Plane angle and solid angles are dimensionless, but they have unit. Okay, there is a question related to that, plane angle and solid angle, and I think we have to say whether they have dimensions and units, or they have only units, no dimensions, and this kind of options were there. So we have already discussed these things, that plane angle and solid angle. These two quantities are nothing but kind of ratio of similar quantities. Plane angle is kind of length by length thing, and solid angle is a kind of length square by length squares. So although we have units for these two quantities, here we have SI unit radian, here we have SI unit radian, but we can't find dimensions because similar quantities are there. So dimension less, but unit is there. Okay, moving to the next question. Which physical quantity has dimensional formula of this one? So we should know some easy formulas for these physical quantities, and then we can come to this point, because look, here we have all fundamental quantities represented. So for example, if we want to know what is the dimensional formula of electric permittivity, so we have to find where electric permittivity is present, and that formula should be simple one, so that we can reduce that to fundamental quantities. For example, let's say electrostatic force. We know that 1 by 4 pi epsilon naught q1 into q2, let's say q square by r square, and then we have to find out dimension for this. So we can write epsilon naught equals to 1 by 4 pi q square by r square into f. Now this is dimensionless, so we have to worry about these three things. Q is I into T, and we have this notation for I. We have time as fundamental physical quantity, and squared we can do this way. And downside here length square, and then we have here m l t to the power minus 2. And now you can solve this to find out whether it is matching with this or not. In the same way, you can do this for magnetic flux, self-inductance, and magnetic permeability. So this is for magnetic permeability. I am just saying answer here, and you can check all these things by yourself by choosing some simple formula and then reducing them to fundamental quantities. So how can you do that? You can do that this thing. Magnetic permeability you will find in Biot-Savart law. There you will find this thing, mu naught by 4 pi, and then I into dl sine theta. Let's say it is dv sine theta by something r square. So this thing is dimensionless, and this thing is dimensionless. So you have to worry about this thing, and this is I, fundamental physical quantity. This is length, this is also length, so there will be A by L, and then here you have mu naught, and then you have to be worried about this B. Where you have got this thing, let's check if you know a part of Lorentz formula where force on a charge moving in magnetic field can be expressed by this thing. So here, from here, you can get B. So B is velocity, that is L t to the power minus 1. Q is I into T. I'm writing this side. I, that is electric current into time here, and then forces M L t to the power minus 2. So from here you can obtain this B. Look, this will be cancelling out, and then you can do it. L will be cancelled out from this side, and then you have B equals to mt to the power minus 2 divided by A here. Okay, I'm leaving next part to you. This you have to put it here, means in place of this here. Here you have to put it, and then you have to find out this thing. This is magnetic permeability of free space. So you will get this thing, and you can check for others. These all things you can take some simple formula from anywhere, and then you can go for simple further simplification so that they can be expressed by using just fundamental physical quantities. So this is correct, and this is magnetic permeability. Now moving to the next question. What is this? The errors in measurement arise due to unpredictable. Oh, this is random one. So you can write simply random errors. Instrumental errors are those uh, which we can see that okay, this is a faulty instrument and it is not going to give us proper result. For example, there is a very simple example for this. If a scale is broken from here, and instead of starting from 0, it is starting here from 2 centimeter, let's say, so it has zero error. This is a kind of instrumental error. Personal error is your personal bias, where you are going to do faulty experiments. You can do some kind of, you say, like you are not using a proper way to do experiments. And least count errors we have already discussed about it. So for better understanding, I'm again emphasizing on the same thing, that you should go through the concept videos, so you will get the idea what are these things. Now moving to next one. Okay, metal wire has mass this much, radius and length. These all things are. So let's say this wire is cylindrical. So we can get, look here, density is mass per unit volume, mass per unit volume, and volume is, in case of uh, cylindrical object, volume is pi r square h. So this is radius, this is length. So r is given here, h is given here, and this mass is given here. But they have some errors. What we need to do, we have to just calculate percentage error. You can calculate percentage error here. This is very easy. 0.002 divided by 0.4 into 100. This is relative error. Error in measurement by the measured value. This is percentage error. Now multiplied with 100. Percentage error in mass, measurement of mass. Okay. Now in the same way, you can calculate what is the percentage error in radius. So 0.001 by 0.3 into 100. This is percentage error in radius. And okay, I'm writing just delta r here for reference. And in the same way, you can do for height also. This one height. Here, this is written as length. You consider it height. So let's say this is cylinder, this is radius, and this is, you can say, length or height, whatever you like to say. So 0.02 is the error, divided by 5 is the measured value, and into 100. So this is a relative error in length and multiplied with 100. Again, we got percentage error in length. And now I would like to go back the slide, the first one. Okay, here, if X is density, this is mass, and this is pi, which is a dimensionless r square here, and h. Look what we did to get maximum percentage error here. We multiplied with power. The percentage error in each case, we got something, and then we multiplied with their corresponding powers, and then we added them. So whatever be the percentage error in mass, we have to multiply with 1, and then percentage error in radius, we have to multiply with 2, and then percentage error in length or height, we have to multiply with 1, or actually we need not to multiply with 1, we have to write it as it is. Okay, so in this way, going back to the final slide. Okay, in this way, we have to calculate this thing as percentage error in mass, this thing as percentage error in radius, then we have to multiply it with 2, then we have to add these all three things to get the final measurement. And you have to do it by yourself, and for your reference, I'm just solving it somewhere else, and then I'm writing the answer directly, and it will be 1.6%. Okay, you can calculate it, and then you can let me know through the comment section if it is coming this much or not. And if our answer varies, we can discuss it well. Okay, so in the next video, we are going to start a new topic, I think work, power, and energy. Because intermediate topics we have already discussed, and you can find playlist there.